video, we're going to examine multiplication of square matrices. So in this case, we have two 2x2 matrices. We have matrix A and matrix B. And we're going to come up with any conclusions that we could make about the commutative and distributive properties for multiplying these square matrices. So the first thing I'm going to look at is I'm going to look at if it is possible for AB, or A times B, to equal B times A. Basically that commutative property. So I have such a hard time saying that. So the first one we're going to look at is A times B. Alright, so I'm going to look at matrix A and I'm going to multiply it to matrix B. So I'm going to start with the negative 2 times negative 1. Then I'm going to add that second part of the row times the bottom part of the column. So this is going to be 1 times 0. Okay, the second one is going to be negative 1 times negative 1 plus 0 times this 0 right here. Okay, the next value in my matrix is going to be negative 2. We're going to go back to the top, times negative 5. We're going to look at that right column, plus 1 times 4. Because remember we are multiplying this way to this way. This way to this way. And then again, we do it again, second time. And now I'm in the second time going down. All right. See if I get that color back. All right, so the next one is going to be negative 1 times negative 5 plus 0 times 4. Okay, looking to see what we're left with here, we're going to get 2 in the 1, 1 location, 1 in the 2, 1 location, 14 in the 1, 2 location, and 5 in the 2, 2 location. Now I'm going to compare it to BA. So again, I'm going to do the multiplication, but in this case, I'm going to go across here and then down this way. So negative 1 times negative 2 plus negative 5 times 0 . Negative 1, negative 2. Oh, wait. Negative 5 times negative 1. I knew there was a mistake there. I don't know where I got 0 from. Negative 1. Alright, and then I'm going to go across this way, down this way. So I'm just double checking. So this is going to be 0 times negative 2 plus 4 times negative 1. Then changing colors here, I'm going to do the second time going this way. That gives us negative 1. Oh, and then, sorry, I didn't keep the color combination here going down that way. So it's negative 1 times 1 plus negative 5 times 0. Never give myself enough space. And then this next one is going to be, I'm just going to keep, actually I'm going to change to this orange. This one's going to be 0 times 1 plus 4 times 0. Okay, so what we come out with, if I don't write so big and off to the side, we have 7, negative 1, negative 4, and 0 for summations there. So is the left squares AB equal to BA? Well, looking at this, it is not. And I know we said that we're looking at square matrix. So a square matrix is a matrix that has the same number of rows as columns. These would be technically looking like a square matrix, but since A and B does not equal BA, the commutative property, oh my gosh, does not hold true for all square matrices. So not all square matrices will have AB equals BA or XY equals YZ, things like that. So in this case, it is not true. All right, so let's look at a second part. We're talking about the distributive property. So let's look to see if A times A plus B, or I like that blue, equals AA plus AB. And again, we have to test the left and we have to test the right. So let's test the left. I think I spend most of the time trying to figure out what colors I like. I'm going to go with yellow. Actually, you know what? I might go with an orange. I feel very orange-like today. All right, so my solution here would be A plus B would equal the matrix of -2, 1, -1, 0 times the matrix -2, 1, -1, 0 plus -1, -5, 0, and 4. Alright, so for PEMDAS, what I need to do is I need to add up everything on the inside. Alright, quite big. So I'm going to try to write a little bit smaller here. -2 minus 1 is -3. 1 minus 5 is going to be -4. That's going to be -1. That's going to be 4. All right. So again, I'm going to multiply by going across and then down. So in this case, we have -2 times -3 plus 1 times -4. Oh no, sorry, -1. And then I'm going to go across and down. So -1 times -3 plus 0 times -1. Next group, across and down. So -2 times -4 plus 1 times 4. And then across and down. So this is -1, -4. It's getting a little bit hard to read with all the arrows. Plus 0 times 4. We'll end up with this blue here. All right, looking at this matrix right here is going to be equal to, let me choose 5, 12, 3, and 4. So this is a matrix A times A plus B. All right, so now we're going to do the AA plus AB. So AA is going to equal -2 times -2 plus 1 times -1. And then -1 2 plus 0, negative 1. Oh, this is playing tricks on my mind because I'm trying to think going down, across, going down, across. Okay, the next one is going to be negative 2, 1 plus 1 times 1. And the last, no, 1 times 0, going down. And then we're looking at negative 1 times 1 plus 0 times 0. Yeah, so I'm just double checking it all because that's a little crazy. Okay, so AA will equal the matrix, let's see, negative 2, 4, so it's going to be 3, negative 2, negative 2, actually, this is supposed to be a negative, so it's 2, and then, I want to say negative 1. Negative, so it's a negative 1, yeah. Okay, so now let's look at AB. AB is going to be negative 2 times negative 1. This will be a little bit easier, plus 1 times 0, then negative 1 times negative 1, plus 0 times 0, I believe. Then we have negative 2 times negative 1, plus 1 times, no, negative 1, 5, plus 1 times 4, and then negative 1 times negative 5, plus 0 times 4. What we will get here is AB is equal to, crazy numbers here, 2, 14, 1, and 5. I did not write that on another layer. So now let's do AA plus AB. So AB will equal 3 plus 2. 3 plus 2 is 5. Negative 2 plus 14 is 12. 2 plus 1 is 3. And negative 1, this is 4. Whew, lots of work just to get to that conjecture. All right, now we see that A times A plus B does indeed equal AA plus AB. So since they equal each other, the distributive property is true for this case. Proving the equation for a specific example is not sufficient to prove the equation for all matrices. So I can't say this is a bold statement that the distributive property will work 100% of the time. But in a case like this, for the square matrices, it works. All right, guys, I know that there was a lot in there, different colors, different strategies. But if you have any questions, always feel free to ask, and I'll catch you in the next video.